All right, guys, so we got here, go to the top. All right, so we are talking about linear inequalities today. What does a linear inequality look like? Let me just give you sort of an example. Write this down. Y is greater than 3x minus 7. So a linear inequality. Yesterday we talked about multi-step inequalities. Today we're talking about linear inequalities. What does the word linear mean? Line, right. So we're going to be making inequalities into lines. What form is this inequality in? What form is that called? It's called slope-intercept form. Normally we think of things that are in slope-intercept form as equations. For instance, y equals mx plus b, right? However, it also can be an inequality. Y is greater than mx plus b. So what would be my slope for this inequality? 3, not x, just 3. And what would be my y-intercept? Negative 7. What is the variable we use to represent slope? M. M is always slope. And what is the variable we use for y-intercept? B. Very good. We're actually going to skip this next part. We're just jumping right down to example number 1, where it says solution or not a solution. Here we go. All right, so test points. This says determine whether the ordered pair is a solution of the inequality. So here's what's happening. It gives me my first inequality, which says 2x plus 3y is greater than or equal to 14. And then it has a semicolon, and then it has the ordered pair 5, 2. Yes? So what it wants us to do is take that ordered pair and plug it into the inequality to see if it works. If it does work, and what do I mean when I say work? If it's true. When I plug it in, if it's true, then that means that it works. If it is true, or if it does work, then I'm going to circle solution, because that point would be a solution. However, if it's not true, or if it's false, then what am I going to circle? Not a solution. Here we go. So this is an ordered pair, so this is an x and this is a y. I'm plugging it in. What am I plugging in for x, guys? 5. So 2 times 5, do this on your paper as well, plus 3 times my y value, which is 2, is greater than or equal to 14. What's 2 times 5? 10. Plus 6 is greater than or equal to 14. What's 10 plus 6? 16. Is this true? That is true. So that means that the ordered pair 5, 2 is a solution. Pretty easy, right? Let's do the next one. So this time I'm plugging in negative 2, 4. So I'm replacing x with negative 2. So 4 times negative 2 minus 7 times my y value, which is 4, is greater than 28. 4 times negative 2 is negative 8. Negative 7 times 4 is negative 28. So when I evaluate these two, negative 8 and negative 28, I get negative 36. So you guys tell me, is negative 36 greater than 28? It is not. So that is not a solution. I'm going to let you do 3, 4, 5, and 6 all on your own. However, notice in number 3, they actually write the y first and the x second. So just be careful as you're plugging in your ordered pair that you plug it in appropriately. All right, so we're moving on to the next page, boys and girls. All right, so guys, this is sort of the meat of the lesson. So we are going to talk about graphing an inequality on a coordinate plane. All right, so here we go. Number 1. Number 1 says y is greater than negative 2x plus 5. Is this guy written in slope-intercept form, yes or no? Absolutely it is. What's my y-intercept? My y-intercept is 5. So I start, do this on your paper, I start on the y-axis at 5. And what's my slope? So I write negative 2 over 1. So according to my slope, what do I do from this point? Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Everybody good? Now, remember back just the other day when we were doing multi-step inequalities and we were doing open circle and closed circle stuff? Remember the open circle, closed circle? That still applies here, except we don't use circles. If it does not have the or equal to underneath the inequality symbol right here, then it's what we call a dashed line. If it does have the or equal to, like it does here, then it's going to be a regular solid line. So a dashed line looks like this. So it's not a solid line. Okay, I know this is different. Just give me a second here, bring it together. Okay, so that's what it looks like. Right, if there's no line underneath it, then it's going to be a dashed line. Okay, now, I'm not done. Yes? Yes, very much so. So Brian asked a question. He said, does it matter which, if it's a greater than sign or a less than sign? It very much matters, and here's how it matters. Every time you graph an inequality on a coordinate plane, you have to, listen, shade. So I'm either going to shade on this side right here, or I'm going to shade on this side. One of them is correct and one of them is not correct. And here's how you figure out which way is correct. Listen, I'm going to pick what we're going to call a test point. The best test point to use is always going to be 0, 0. Okay? And I'm allowed to pick 0, 0 for this test point because 0, 0 is not on my line. So what I'm going to do is I'm going to plug the ordered pair 0, 0 into my inequality just like we just did with those previous 6 questions. If 0, 0 works, then guess what that tells me about 0, 0? It's a solution, which means that I would shade over the 0, 0. The shaded region of the inequality represent all of your solutions. Are you with me? So let's plug 0, 0 into this inequality and let's see what happens. What do I plug in for y? 0 is greater than, what do I plug in for x? What's negative 2 times 0? What's 0 plus 5? 5. Look at this inequality right here. Is that a true statement or a false statement? 0 is not greater than 5, so that means since when I plug this point into this inequality and I got a false statement, guess what that tells me about this region? It's not the solution. So where do I shade? I shade over here. Listen guys, if I plugged in any of these points in this shaded region into this inequality, guess what would happen? It would work. Let's pick a point. Let's go 4, 2. This point right here. See 4, 2? I'm going to plug in that ordered pair. Watch what happens. What am I plugging in for y? 2. I'm plugging this ordered pair right here in. 2 for y. And then negative 2 times 4 is negative 8. And then negative 8 plus 5 is negative 3. Tell me, guys, is 2 greater than negative 3? Yeah. It is. You don't have to do this every time. I'm just showing you. Every single point, guys, that's in the shaded region, if you plugged into the inequality, would work. Every time. Any questions? Let's do the second one. And you're going to have a lot of questions. That's okay. But we're going to do lots of examples, and you're going to hopefully have it by the end. This one says, it looks a little bit different, but actually this guy is in slope-intercept form as well. What is my slope here? 1. And what's my y-intercept?
0.
It's 0. There's an invisible plus 0. So this guy, I'm going to start right here. What's my slope? 1. Don't say 1, 1. You say 1 over 1. So from here I go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Instead of doing up 1 to the right 1, I can go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1. Is this going to be a solid line or a dashed line? Absolutely. So I'm going to connect everything and make sure I have arrows on the end. Connect everything. Make sure I have arrows on the end. Now, In this case, guys, I am not allowed to use 0, 0 as my test point. Why is that? Because it's part of the line. It's on the line, so I can't. So I have to choose another point that is not on the line. So how about this guy right here? What is this ordered pair right here that I just kind of circled? That ordered pair is 2, 0. So I'm going to take that point and I'm going to plug it into my inequality. If it's true, or if it works, then where am I going to shade? I'll shade over my test point. But if it's not true, then where do I shade? On the other side. Let's go. So what am I plugging in for y? 0 is greater than or equal to, what am I plugging in for x? 2. Is this a true statement? Is 0 greater than or equal to 2? It is not. So guess where I shade? On the other side. I shade over here. If it doesn't have the or equal to, then it's dashed. If it has the or equal to underneath, then it's going to be a solid line. Now, there are two concepts, two nuances that I got to tell you about that are very important. Your question? Okay, and here's the first. Now, you got to listen really well to these or else it won't work. So put your pencil down when you're ready. Do not move on. Ari, do not move on. All eyes up here. You made the video. All right. So, this guy, we have not talked about the difference between a dashed line and a solid line. Well, like, why do we do that? And here's why. If I were to go back to my original problem and pick this point, what's this ordered pair right there? What ordered pair did I just highlight? 1, 3. That point is on the dashed line. So what I'm going to test is, I'm going to test to see if this point is a solution. I'm going to test, okay, so basically what I want to know is, I want to know if the points on a dashed line are solutions or not. So let's take this point and plug it into this. So what am I going to plug in for y? 3 is greater than, what am I plugging in for x? 1. What's negative 2 times 1? Negative 2, and then what's negative 2 plus 5? 3. Is this a true statement, yes or no? It is not a true statement. So guess what that tells me about this point? It's not a solution. Let's test another point. How about this guy right here? What is this ordered pair right here? Is 4, negative 3. Let's plug 4, negative 3 into my inequality. What am I plugging in for y? Negative 3 is greater than, negative 2 times 4 is negative 8. Negative 8 plus 5 is negative 3. Is this true? No. So this doesn't work either. So here's the concept. Every single point that is on the dashed line is not part of the solution. Think about it. If this had an or equal to underneath, then would they then be part of the solution? They would, because these would be or equal to or equal to. So here's the concept. Every point that's on the dashed line, none of those points are part of the solution. However, every point that's on a solid line are part of the solution. They are part of the solution. Are you with me? So the question is, well, why is that important? Well, when you go, you need to know, if I gave you any random point, let's say this point right here. You tell me, guys, is this point right here part of the solution? No. How about this point? Is that point part of the solution? Yes. Absolutely. What about this point? Is that part of the solution? No. What if I go over here? Is this point part of the solution? Yes. Is this point part of the solution? Yes. Is this point part of the solution? No. You got to know what's a solution, what's not a solution. Are you with me? So that was nuance number 1 that we need to talk about. Number 2 is this. There's actually a cheat in, remember how we did the test point and did all that work? You don't have to do that. I don't have to do that because I understand how the cheat works. And here's how it works. If we look at this, it says y is greater than negative 2x plus 5. If we look at our line, well, what side of the line kind of looks like more than the line to you? Above the line or below the line? Above. So you should have known, or you didn't learn yet, but now you can know that I'm going to shade here every single time. if it says like that. Look at this. What does it say? Y is greater or equal to than X. Well, if this is your line, what side of the line looks like greater than the line? Below it or above it? Above it. This was the side we shaded on. It's a good way to check.
There's an exact amount on this side.
Okay, that's fine. It has nothing to do. Because think about it, guys. A coordinate plane goes forever. This is just a very small snapshot. We don't pick the side which side is more. We're looking for the We're looking for the side that's actually greater than. We'll do more examples. It's all right. That's all right. We'll get it. All right. Let's do number 3. Is number 3 written in slope-intercept form? It is. It's just backwards. So you have your y. What's your slope for number 3? What's your slope? 3 over 1. And what's your y-intercept? 0. So where am I going to start here? At the origin. And what's my slope? What do I do? Up 3 to the right 1. Up 3 to the right 1. Instead of going up 3 to the right 1, I can go down 3 to the left 1, down 3 to the left 1. Is this going to be a solid line or a dashed line? It's going to be dashed. Very good. Okay, am I allowed to use my favorite test point of 0, 0 here? I am not. So let's use this test point. What is that test point right there? 2, 0. So let's plug 2, 0 into my inequality to see if it works. What am I going to plug in for x? So what's 3 times 2? 6 less than, what am I plugging in for y? Is this a true statement? Is it true that 6 is less than 0? It is not true. So since, guys, listen, catch this. Since when I plug this test point into my inequality, I got a false statement. That means that this side is not the solution. So what side is the solution going to be? The other side. Yep, let me show you. Watch. Let's read this from the side that has the y on it. It says y is greater than 3x. Okay? Do you see this guy right here? See this line? Well, what side of your line looks like it's greater than? This side. This side's going to be below. This is below the line. I want the stuff that's greater than. I want above the line. Let's try this one. This guy, the only difficult thing about this is that you just need to understand that f of x is the same thing as y. So I want you to rewrite the equation. Y equals 2/3 x minus 1. Okay, and now I'm in slope-intercept form, which is great. So where do I start on my line? Start at -1. What's my slope? So what do I do? Up 2 to the right 3. Up 2 to the right 3. Instead of going up 2 to the right 3, I can go down 2 to the left 3. Down 2 to the left 3. Is this going to be a solid line or a dashed line? Absolutely. Okay. Can I use my favorite test point of 0, 0 here? Yeah. Now listen, before I do that, let's look at this. What does it say? Y is greater than. So guys, where is going to be greater than the line? Above the line or below the line? Above the line. So I expect, according to the cheat that I'm going to be shading here, let's see. So I'm going to plug the ordered pair 0, 0 into my inequality. So what do I plug in for y? 0 is greater than or equal to, what's 2/3 times 0? 0. And then what's 0 minus 1? -1. Is this true? Is 0 greater than? It is. So since when I plug this point in, it worked, where do I shade? I shade right there. So remember my cheat that I did? Was my prediction right? Sure was. The cheat worked. Guys, how is number 5 tricky? Guys, does anybody have any questions? I know we're rolling through these pretty quickly. We're going to get a lot of time to practice at the end. Yes, sir.
I'm still a little confused on the dotted and closed sign. I mean, not dashed.
Dashed and solid. If it has the or equal to underneath, then it's going to be solid every time. If it doesn't, then it will be dashed every time.
Filling in all the spaces. Right.
Make sense?
Yeah.
Let's move on to number 5. Guys, how is number 5 a little bit trickier? It's not in slope-intercept form. I couldn't have said it better myself. Absolutely. So we have to be able to put it in slope-intercept form. Guys, and let me just be real with you. Rearranging things and being able to put lines and inequality or equations and lines in slope-intercept form is a critical skill that you must have to pass the SOL. You've got to have it. If you don't have that skill, it ain't happening. So we got to learn that. So if you don't know how to do that perfectly yet, we got to get you there. All right. So I want to get y by itself. So I need to move the 3x and the negative 9. Which one do I have to move first?
3x.
Why the 3x and not the negative 9? Can you explain it to me? The y is attached to the negative 9, is it not? It is, thank you. So how do I move 3x to the other side? Good, subtract 3x. Subtract 3x. So what do I write? I'm going to bring everything down. What do I have? Negative 9y is greater than or equal to. Good. What? Perfect. Now, am I in slope-intercept form yet? I'm not. What do I still need to get rid of? The negative 9. And how do I get rid of that negative 9? By dividing by negative 9. Guys, remember what we learned last time? When you divide an inequality by a negative number, what happens to it? Flips the other way. So I divide everything by negative 9. So I get y. What happens here? Goes the other way. What is this? What does that turn into? You guys, you have to know how to simplify this. It's 1/3. I never write a slope as a decimal, ever. I always write it as a fraction. Can you give me a few minutes? So this is going to be 1/3 x. 27 divided by negative 9 is negative 3. Guys, I want you to look at this right here. Look at this inequality that I just wrote. Does anybody have a question on how I got there? Now let's graph it. Where do I start? My slope is up 1 to the right 3, up 1 to the right 3, or down 1 to the left 3. Down 1 to the left 3. Is it going to be solid or dashed? Solid, right? Now, let's make a prediction and then let's use the test point. This says what? Y is less than or equal to this. So here's, where would less than be, do you think? Would it be above or below? Below. Let's do my test point. My test point is, so I expect when I plug 0, 0 in, do I expect it to work? No. I'm going to shade here. So I know that when I plug this in, guess what? It's not going to work, but we're just confirming that. So I'm plugging 0, 0 in. What do I plug in for y? 0 is less than or equal to. 1/3 times 0 is 0. 0 minus 3 is negative 3. Is it true that 0 is less than or equal to negative 3? No. Shade here. Guys, you don't have to know how to do the cheat. You do not have to. It's very helpful. But just know. How are we? I'm going to do number 6 with you, and then I'm going to do 1, 2, 3 on the next page, which are very quick, and then we're going to work for about 15 minutes, and then we're going to do IXL for the last 15 to 20 minutes of class. Yes? No, not yet. Here we go. Number 6. What do I need to do? What do I need to do to number 6 first? Tell me. Nope.
2x.
There we go. Subtract by 2x. Subtract by 2x. Subtract by 2x. So then I'm left with this still. Don't drop the negative sign. Negative y is less than or equal to negative 2x plus 4. Guys, how do I get rid of that negative sign?
You divide by negative 1.
Is he right? Absolutely. When I divide by a negative number, what happens to my inequality symbol? It flips the other way, so I'm left with y is greater than or equal to, what does this become? 2x, right? And then what does this become? Negative 4. Absolutely, you guys are doing a great job. Negative 4, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. We're down 2, left 1. Is this going to be a solid or dashed line? It's going to be a solid line. Which side do you think I'm going to shade on? The top side, right? It says greater. When we're looking for greater, we're looking for the top. So I'm going to be over here.
Why'd you have to switch the symbol?
Because it divided by a negative number. Anytime you divide an inequality by a negative number, it flips.
I get it.
Every single time.
So the negative number is a finger that pushes it to. I get it now.
All right. Moving on, graph the inequalities. Guys, you have to be able to recognize that these are special. How are these special, or how are these different than the ones that we just did? Every single one, 1 through 6, have only one variable in them. Exactly right. They're either just a y or just an x. Now, if it's just a y, what kind of a line is that? That's a HOI. That's a horizontal line. And if it's just an x, what kind of a line is that? It's a vertical. It's a vertical. So, this guy right here is a horizontal line. So it's a horizontal line. Is it going to be solid or dashed? Dashed at negative 2. Watch how easy this is, guys. This is where the trick really comes in handy. Guys, this says y is greater than negative 2. Well, where are the y values that are greater than negative 2? Are they above it or below it? Above.
Oh, that was easy.
Super easy.
How'd you do that?
What does this say? Y is less than 3. So right away I see that. What kind of a line is it? It's a horizontal line at 3. I know it's going to be dashed. Very good. Now, what does this say? Y is less than 3. So where are the numbers on the y-axis that are less than 3? Below. Make sense, guys? Let's go on to number 3, and then you guys are going to finish, and then something else. Number 3 is also special. It only has a what? It only has an x. So what kind of a line is it going to be? A vertical line at 4. Is it going to be solid or dashed? Now, what does it say? X is what? Less than or equal to 4. Well, look at the x-axis. Where are the numbers that are less than or equal to 4? Are they to the left or are they to the right? To the left. Someone should make a song that starts off to the left, to the left. That's a good idea. Oh, there is?